Assalamualaikum. My name is ZATY ZAINAL. My metric numbers are 2018-259748. My supervisor's name is Dr. Nurmaisara Sarizan. Today, I would like to present to you my thesis topic, which is a review on biosorption heavy metals from solutions by BIVALVE shell powders. First of all is introductions. The background of study for this thesis have several main points, which are heavy metals, biosorption, and BIVALVE as biosorbent. Heavy metals are stable, non-biodegradable, toxic materials which can accumulate within the body of organism and will contaminate it. Hence, biosorption method is the most preferred due to its potential and cost effectiveness. Even though a lot of types of biosorbent have been used, but in this review, I will talk about bivalve shell as potential biosorbent, as it is generally a cancerous exoskeleton that encloses the cover part, the soft part of the organism. Next, in this review, the problem statement are toxicity of heavy metal in wastewater. This is due to high risk which is associated with human health even at low concentration. For example, high amount of copper may lead to Wilson disease, anxiety, insomnia, and others else. Then, many conservative treatments have been used for the removal of heavy metals such as chemical precipitation, reverse osmosis, and ion exchange. But all of these methods are costly, and the worst, it can cause secondary pollution. For information, seashell always been dumped as a waste from restaurants, factories, and all of this will lead to many environmental problems, including pollution of coastal fisheries, management of public water surface, bad smell, and damage to natural landscape and health. This review is significant in order to produce a biosorbent from raw materials, which is the bivalve shells that are available in abundance and commonly treated as waste but have a great ability in absorbing heavy metals. Next, this review also can provide an alternative way to recycle the bivalve shells, which are commonly dumped as a waste to more valuable uses. And also, the result of this study will provide information on the most suitable physiochemical conditions for biosorbent of heavy metals using bivalve shell powders. The objective for this study is to review the bioabsorption capacity of different bivalve shell powders on heavy metals. Second, to analyze the effect of various cycle parameters such as pH, initial concentration, solvent dosage, temperature, and also contact time toward heavy metals. The last part of introduction is research question. First, what are the available techniques available for the removal of heavy metal in solution? Second, what is the bivalve species that have been used as the biosorbent for the biosorption studies? Third, how does the biosorption capacity of different bivalve shell powders could affect the removal of heavy metal in a solution? Fourth, what are the optimal physicochemical parameters, pH, initial concentration, solvent dosage, contact time, and temperature of various types of bivalve shell powders, and how it could affect the biosorption capacity. Lastly, which isotope model can describe the best biosorption process on heavy metal of bivalve shell powders. The second part of this thesis is literature review. Why bivalve shell has potential for biosorbent? Bivalve hard shell are made from calcium carbonate and three monomer, namely aragonite, venterite, and calcite. Bivalve shell also had been evaluated and very diverse and had shown a good biosorption capacity. Besides, bivalve shell also could offer adequate and effective antisite for biosorption of heavy metal due to their unique functional group. Then, clamshell species have proved that it can absorb more heavy metal compared to other species. For example, DUEL 2011 had reported the highest absorption capacity for razor clamshell, which are 501 mg, 557 and 657 for cadmium, lead, and zinc metal ions. The table shows the amount of various metals ion that absorbed by bivalve shell. The review is effect of parameters. The optimum pH 6 was clarified of removal of cadmium, copper, and lead ion using Lala clamshell. The similar result also show for the removal of lead ion using mussel shell as biosorbent. This is because pH value during the biosorption process may affect the absorption site on the absorbent surface and the degree of ionization of the heavy metal during reaction. Next, initial metal concentration. The absorption of metal ion of copper, cadmium and Pb increase with initial concentration when using oyster shell as low-cost absorbent. The initial Pb2 plus ion concentration increased from 20 mg per liter to 100 mg per liter. The biosorption capacity increased from 14.72 mg to 57.79. Besides, when initial metal ion concentration increase, the percentage removal efficiency will decrease, whereas for biosorption capacity will increase. Therefore, it can be concluded that when the initial metal ion concentration increase, the percentage removal efficiency will decrease due to limitation of active site on the absorbents, which become saturated at above maximum concentration, whereas for the biosorption capacity, it will increase due to higher absorption rate and the utilization of all active site available for the absorption at higher metal ions concentrations. The biosorption capacity decreased from 82.42 to 26.03 when solvent doses increased due to an increase in an active site and penetration of metal ion onto absorbent site. The absorption efficiency will also increase. The biosorption efficiency will increase when increasing the solvent doses because more binding sites are available. However, the biosorption capacity will decrease due to biosorbent active sites are not saturated. Smart clarified that when temperature from 25 degrees to 75 degrees Celsius, the biosorption capacity for argentum arsenic was decreased from 94.34% to 87.77% and 92.12% to 84.36% when using oyster shell. Recent study claimed that the absorption capacity increased when temperature higher when using calcium mussel shell for removal of Pb2 plus ion from 53.86 mg to 65.42 when temperature increased from 90 to 34 degrees Celsius. Therefore, it can be concluded that the biosorption capacity of biosorbent will increase when temperature higher due to decline of electrostatic forces between metal ions and also active sites of absorbent surface. The optimal contact time for elimination metal ions was found to be 7.5 minutes for copper 2 plus ion and 10 minutes for lead 2 plus ion. The quantity of heavy metal ion that absorb onto oyster shell powders increased speedily when contact time increased, then have a tendency to be stable. The last part of literature review is acetone model. Lamiel model explains the concerns of monolayer absorption on the absorbent surface where all sides are equal, whereas for Freundlich model explains the reversible and non-ideal absorption process. To conclude, the effect of various parameters such as pH, initial concentration, solvent dosage, temperature, and contact time had been analyzed. The absorption isotone was revealed that BIVALVE shell powders fit with Lamiel and Freundlich model. For recommendation, most species of BIVALVE need to be tested for their biosorption capacity, such as by using scallop for removal of heavy metal. Last but not least, further study is needed to identify the characterization of BIVALVE shell, such as by using scanning electron microscope, Fourier transmission infrared, and also X-ray diffraction. That's all from me. I hope my examiner will enjoy watching this video. Thank you.